These intelligent AMI solutions will solve many problems from the existing manual process. We can reduce time and money spent metering manually. We can manage blackout and loss during distribution. We can do demand response, TOU. Finally, we can make grid smarter. AMI service. Meter reading information of household is call-seated by modem and DCU. There are two types of smart meter, internal and external. Smart meter sends metering data to modem via serial communication. Modem sends metering data to DCU via PLC communication. DCU sends metering data to server via fiber optic and cellular network. On-time monitoring and detection of electrical loss. TOU, time of USC flexible tariffs. Connectivity to electric vehicle charging system. Connection of renewable energy and battery with bidirectional metering. Reliable collection rate improving, monitoring of power quality. Making grid smarter and more efficient. A hidden champion in the energy IoT solution industry. Tide.
At ABB, we're creating buildings of the future today. This is made possible by our cloud infrastructure, known as ABB Ability. Our fully integrated smarter building systems deliver higher value than individual smart components. By adjusting a building's energy consumption to meet demand, our connected solutions provide savings of 30 to 60%. Wherever energy comes from, we ensure it arrives safely and reliably at the point of consumption. Our building automation allows control of every detail, from anywhere at any time, whilst our smarter security systems detect and communicate threats or faults before they become a problem. From factories to offices to homes, at ABB we are working to find more sustainable, safer and smarter ways to power the world around us. Bringing the future to you today.
The various stakeholders in the French smart grid sector may be found on this diagram: network management and operations. These solutions deliver cost savings and technical improvements to networks. New uses. These solutions encompass e-mobility, smart homes and smart buildings. All of the prosumer. Prosumers are active participants in the energy market, thanks to smart meters and self-consumption. Integration of renewable resources. These solutions help manage the challenge of renewable energy intermittency. Use of data. Energy data is put to use to offer new services to consumers and local authorities. Research and expertise. Members of this sector offer smart grid-related training and consultancy services. France, including overseas departments and collectivities, aims to generate 32% of the energy it consumes from renewable sources by 2030. Since 2008, 121 pilot demonstration projects around the country have helped hone France's expertise in smart grid operational technologies and features. From 2008 to 2014, €500 million has been invested in R&D, putting France top of the European League. Now, this experience and the French government's call for proposals for large-scale smart grid projects has resulted in projects being rolled out in several regions by the successful applicants: FlexGrid, UNGrid and SMILE. These smart grid projects span several regions and focus upon the 6 key aspects of the French smart grid sector, promoting French expertise in this field on the international stage.
Indonesia mengembangkan energi baru terbarukan melalui berbagai fitur pembangkit listrik untuk menghasilkan energi bersih dan juga tetap menghasilkan tenaga listrik yang dapat dimanfaatkan oleh masyarakat. Ini aku dan keseharianku. Semakin intens menggunakan segala perangkat yang berhubungan dengan tenaga listrik. Listrik kini menjadi kebutuhan pokok sehari-hari. Listrik sangat mempermudah kehidupan kita. Dari energi bersih menjadi listrik. Listrik berkontribusi menciptakan lingkungan yang lebih sehat.
Negara Indonesia adalah negara kepulauan yang terdiri dari 273 juta penduduk Indonesia yang kaya akan potensi sumber daya alam. Kondisi saat ini, rasio elektrifikasi Indonesia guna memenuhi kebutuhan listrik masyarakat di seluruh pelosok masih belum mencapai 100%. Indonesia juga masih menjadi negara penyumbang sampah terbesar yang sampai saat ini belum mencapai target pemerintah. Berdasarkan problematika tersebut, sebuah terobosan pengelolaan sampah menjadi energi dengan teknologi olah sampah di sumbernya atau dikenal dengan TOS akan menjadi solusi masalah sampah yang didominasi oleh sampah biomasa seperti daun, ranting, rumput, limbah perkebunan, limbah pertanian, dan juga sampah organik lainnya.
Mudah-mudahan program ini bisa menjadi program nasional dan bisa banyak dukungan-dukungan kami sebagai startup company bisa terus berkembang dan bisa bersosialisasi bersama masyarakat dan UKM-UKM yang ada di Indonesia.
Ladies and gentlemen, may I have your attention, please? The webinar is about to begin. Honorable speakers, distinguished guests, ladies and gentlemen, good afternoon for those who join the webinar from all around the world, especially in Indonesia. Let me introduce myself. I am Syarif Hidayat from Institute Teknologi Bandung. On behalf of the Indonesian Electric Power Society, or MKI, I would like to welcome you all to the 10th episode of webinar entitled Meeting the Electricity Challenges of Smart Building and Industrial Automation Trends, or readiness in Indonesia, which is supported by PT PLN Persero and sponsored by Tide, Huawei, and ABB in partnership with Think Smart Grid Friends and Energy Academy Indonesia, or EKADIN. Today's webinar is the last episode of MKI Smart Grid webinar series. Out of 10 episodes hosted by the Indonesian Electric Power Society, or MKI, taken place in April 2021 to January 2022. Smart building and industrial automation trends continue to unabated, relying on new technologies and approaches to achieve higher comfort, reduce carbon footprint, and improve costs. The adoption of these technologies introduces challenges in terms of energy efficiency, miniaturizations, and system reliability. Today's webinar will feature worldwide electricity companies and expert communities to discuss the critical electricity challenges faced by today's smart building and industrial automation, and explore the readiness of Indonesia electricity system for over
Did I lose my connection or no? Okay, all right.
We will collect the questions and address them during the Q&A sessions. There will be 2 Q&A sessions in this webinar. There will be a presence form posted on chat room in Zoom and live chat in YouTube. Please fill in. You will receive a certificate for this webinar participation via email within 7 working days at the latest. The webinar presentation material will also be sent to your email. The webinar is also live streamed via YouTube channel MKI IEPS and remains there after this event finishes. Ladies and gentlemen, as requested by the organizing committee, we will have a photo session with all speakers. So please, all speakers, switch on your camera for a while. We will count down 3, 2, 1 for taking a picture. The committee will take the picture. Okay, ready? Finish? Okay, thank you. Now, we would like to introduce our keynote speaker, Pak Hammam, as a principal engineer of ORPPT, formerly BPPT, and the president of Technology Audit. Without any further ado, I would like to welcome Pak Hammam to deliver the keynote speech on smart building and industrial automation. Are we ready? So, Pak Hammam, the Zoom is yours for 15 minutes.
Thank you, Sharif Hidayat. I should call him Professor Sharif Hidayat. Yeah, soon to Professor. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings, everybody. Very good afternoon to all of you, especially to all the speakers attending this very interesting sessions, the 10th MKI Masyarakat Kelistrikan Indonesia Smart Grid webinar series, and I'm very happy to be part of this webinar so that we can really, discuss about the electricity challenges, especially on smart buildings and industrial automation trends. We will eventually hit the keywords energy resiliency at the end of my presentation, and of course smart grid will be aligned to that energy resiliency topic. So let me share my slides to all of you. I would like to start the speech by posing a question. Actually, it's a typical questions that are we ready to embark in building smart building and industrial automations. So I will be talking from my role as engineer, former chairman of BPPT at National Research Innovation Agency. I'm also the president of the Indonesia Technology Auditor Initiative. And lastly, I'm also the president of the Collaborative AI Research and Industrial Innovation Associations. We start with a very trivial definitions of smart buildings. Smart building is defined as a collaborative ecosystem. Again, I would like to highlight the word ecosystem of telecommunications, building automation, system integration, and office automation for achieving, okay, what do you want to achieve with smart building? Of course, we want to be optimized in terms of efficiency, compliance, conformability, functionality, and stability of an artificially intelligence building. I put the artificial in the especially not to highlight the artificial part, but intelligence building is. So because we are pursuing energy efficiency and green building for the nature of friendly environment. So based on these definitions, ladies and gentlemen, the smart building should be able to control itself. It's a self-reflection, self-operating, self-intelligence, right? Which, you know, probably not interfering with the human decision making, but it should replicate or mimics the human decision making in automated building control and to optimize operation to lowering costs. So the smart building is basically a concept where we provide automation technology for our convenience, and certainly it will also provide you not only efficient technology like lighting, AC or the other appliances, but also you should be aware of the needs for having such tools. Okay, having such tools that can control the energy usage and in fact data-driven operations by considering the factor of the cooling degree day, occupancy, and operation time. And the challenge in this building smart building is how to actually convert appliances operated manually into an automatically one. Okay, the one that is driven by the data, the one that is driven by the sensors, the one that can be driven and operated using so many variables in optimizing the building. So if we look into the component of smart building, I think I'm sorry if this something like repetitions. I believe all the speakers are very well aware of this. Okay, energy, lighting, fire, monitoring 24/7. You can also include the electric vehicle charging stations and many other electrical appliances. Yeah, whether it is water, the HVAC, elevators, you name it. Yeah, that is all inside a building, and which we want it to be smart, to be better. Yeah, not only smarter but better in optimizing and controlling all the required. So we are looking for this benefit of smart building: reduce energy consumptions, improve building efficiency. Smart technology identify the overuse and underuse areas in the building, providing the opportunity to optimize the utilization of space, which of course at the end you will be saving a lot of money. Yeah, you want to cut the cost of operating such building. Again, this is my something that hits me very much, because we are into artificial intelligence, predictive analytics that that will take us into predictive maintenance of building performance, and probably activate certain procedures, early warning system. Yeah, okay, for operating this smart building. We are looking for this predictive analytics and try to gather the big data of smart building which can be certainly obtained from all the sensors, the IoT sensors, put into the cloud, and certainly do machine learning and deep learning on those data, whether it is coming from CCTV, the image recognitions, face recognitions, to identify people moving in the building, and how you can then better use of the resources, okay, by having this predictive analytics of the smart building. So there are a bunch of technologies really into this, and we cannot only list some of this here, because the list can go on and on, okay, with the industry 4.0 technologies. You not only relies on automation devices, you are not only building analytics using AI and big data, you are also trying to integrate the automation system and then do connectivity across all the floors in the building and all the area in the building, and you try to really make a real-time decision making in order for us to really control and operate the smart building technologies, right? So in our case in BPPT, smart building technology, we call this system informasi dan manajemen energy, because we concentrate on energy conservation and energy efficiency. We have identified, okay, some of the significant parts of smart building technology. Take, for example, monitoring the energy usage and all the variable. This is data-driven monitoring system. We are looking at significant energy usage monitoring, real-time occupancy monitoring, which is an AI algorithm for detecting and monitoring employee occupancy in the building. Of course, again, IoT is being very important here in order for us to collect data, to accelerate, simplify, and expand the area of implementation of energy conservation technology. We certainly need to have the development of IoT dashboard, appliance smart control, and forecasting, predictive and forecasting for recommending the energy efficiency recommendation. And in order to achieve that, you have to put this research and innovation framework into what is really our national program. So it should be this program should have an outcome, in the competitive and economic growth. Of course, then it's all about energy resiliency, ketahanan energi, and at the end, probably we will look into net zero emissions and green environment and green building, and eventually it will have a significant impact on climate change, right? And in order to get this outcome, you have to identify the output, and based on the sourcing of this information coming out from the Ministry of Energy and Mineral Resources, you look at the supply side and on the demand side. I think all of us talking about power, talking about smart grid, talking about electricity should, understand deeply about the supply demand of electricity. And at the end, you can really come up with a program to actually, even if you are just discussing about a smart building, but at the end, you need to have certain programs that can support, the outcome. Name it as energy audit, and investment grade audit, the energy management system. We can look into the efficient energy technology, and also the compliance part of having a standardization for all the energy appliances and many other things. Okay, and this is where the smart visions come in, because it brings all the available technology, whether it is digital intelligence, real-time communications, and many other technologies such as Internet of Things and sensors, sophisticated sensors here, and advanced coordination strategies are needed to have this organized into a smart grid visions. The demand side resource participate with distribution of equipment in the system operation. So consumer engaged to mitigate peak demand and price spikes, for example. Yeah, you have to have also provide demand side auxiliary services to support. For example, if we are talking about the renewable energy sources, whether it is coming from solar power or whether it is coming from the integration of many other renewable sources. So distributed energy resources, and again, the process of digitalization, and I see a good terms for actually bringing up the smart grid vision is ABCD. Okay, Pak Sarif, the new term for me is ABCD X actually. Yeah, ABCD X. A for AI, B for blockchain, C for cloud, and D for data engineering or data driven. You can say that. Yeah. And X, what about X? X is about anything else that is needed. Take it, for example, IoT, or X can also mean mobile, or X can be mean broadband. This is how you relate and connect all the resources into one single platform of integrations. And this is something that really strongly support, and that's why our session today talk about smart building and industrial automation, because automations is the way that we can implement smart buildings. Yeah, automation replace the human involvement with the use of logical programming commands and powerful machineries. So in this case, we can use artificial intelligence, whether it is machine learning, deep learning, NLP, and computer visions, for example. And all this, I think other speakers will enhance and resolve in depth and talk about this in particular details about industrial automation. But what I see coming forth, all of the word for PLC, PC, and PAC technology will be part of the industrial automations. So if we talk about why industrial automations is needed, because there's so many advantages for automation system. We can say a few things about this, about productivity, about optimum cost of operations, whether it is about product quality, to do routine checks, and how to provide the level of safety. Industrial automation increase the level of safety to personnel by substituting them with automated machines in hazardous working conditions. You can replace this with robots, but you cannot ask for the robots to service you by heart, okay, melayani dengan hati, yeah. But of course, robot can be transparent. Of course, robot can be accountable, yeah. And traditionally, industrial robots and robotic devices are implemented in such risky and hazardous places. But it's not a robot that can serve you human-like, human touch. Okay, and this is something that we can discuss later on in other sessions, on how ethical artificial intelligence, trustworthy AI can be part of the automation system. So coming back to the questions, are we ready? I think automation, including AI, is already transforming how we work. Yeah, the Indonesian economy is becoming more automated now. In fact, the president already talked about digital economy, blue economy, and green economy. So we are trying to be among the top 10 countries in the world by 2030. So anything that can be brought up as an innovations will drive this economy. And automation is changing the tasks performed by Indonesian workers, I believe. Jobs can be broken into the very specific tasks, and the automation is part of our business process now.
You have only 2 minutes, 3 minutes.
Okay, I'm getting to my last slide now. Automation is improving the business productivity and worker incomes. So the good news is Indonesia automation industry growth is quite significant, yeah. And I think many of the speakers will represent this automation industry, and I'm cheering all of them to really leverage on the new economy of Indonesia by having an economic impact of what we are doing here through MKI, right? Collaborating and orchestrating the significant innovation to be implemented in Indonesia. So, and I'm also asking everybody to join KORIKA, the Kolaborasi Riset and Inovasi Industri Kecerdasan Artifisial. We will do also an orchestration of industry, government, and academic, as well as community, because we are moving from government-driven association into community-driven association, where we work with all the quad helix for implementing ethical artificial intelligence, which is legal by market. With that, I would like to end my presentation. Thank you so much for having me, and I look forward for some question and answer. Thank you. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Hammam, for your very interesting presentation. I see there have been 2 questions here in the chat and Q&A. First is posted by Pak Hendra Dermawan in bahasa. Pak Hammam, kami mau tanya bagaimana
ya, Pak,
dan bisakah kita menerapkan smart building teknologi di building lama? Berapa budgetnya yang dibutuhkan? So in English, Pak Hammam, could you please tell that is it possible to implement smart building technology in all buildings, and what is the budget?
Ya, terima kasih untuk pertanyaannya. Should I answer in bahasa instead of English, or should I'll do code switching, okay? I'll do code switching. Yeah. So, of course, Pak. Of course, this is about digitalization. It's digital transformations. All building can be equipped with all the necessary sensors and all the automation that is required. Yeah. So it's not that you have to rebuild the building from the ground up, but certainly you can adapt to these new technologies by I don't want to say refurbishing, because you know, there are certain ways of how you can make this building fully connected with the automation, and of course at the same time you achieve the outcome of what you are supposed to have when you build up the building from the ground up with the smart building concept. Jadi bisa Pak.
Oke.
Semua gedung yang lama itu tidak harus dihancurkan untuk kemudian dibangun kembali gitu dengan konsep smart building. Tetapi kita bisa membuat gedung itu menjadi pintar dengan menerapkan otomasi, ya, otomatisasi, menerapkan sensor, membangun middleware untuk bisa berinteraksi antara sensor dengan sebuah dashboard pengoperasian daripada smart building tersebut. Saya kira demikian Pak.
Thank you, Pak Hammam.
Singkat saya.
Hoping that your answer can address the question from Pak Hendra Dermawan.
Yeah.
The second question is from Rizky Ananda Ramadan from Universitas Pajajaran. The question is, how is the policy support by government for the development of smart building technology? Is it an example of government building implements the concept?
Ya, sebenarnya kalau if we talk about whether the government is supportive about a smart building, actually the government is actually putting a challenge to all the, at least that I know of the ministries and all the agencies, the government agencies building, each year they will run a challenge to have the most gedung hemat energi, ya, gitu ya, gedung hemat energi. That means that the energy efficiency are being judged, you know, to each and every building of the government buildings, whether it is in the ministerial or in the agencies, or even more in the regional government. Yeah, and I think this is a good practice because it builds the awareness of having a smart building. Currently, with the new normal, you can see that all the buildings are using at least that you need to come into that with really identified Peduli Lindungi, for example, just to make sure all the tracing and screening of COVID-19 is done at the entrance of the building. That is a smart. And at the same time, you can also do, let's say, if we are coming back to the office currently, that you need to do presensi, ya, absensi istilahnya kalau kita, tapi ataupun presensi. And that is a smart identification in the working, ya. Jadi pemerintah mendorong untuk kita memasuki era smart building. Karenanya tidak heran ibu kota negara baru, ya, yang sedang dirancang dan dipersiapkan, itu konsepnya semuanya adalah smart building. So even though we don't have enough regulation and guidelines, but certainly we are on the track, yeah, on the way to get a complete regulations, and we need to harmonize this with a global standard or compliance standards, yeah, of smart building. That's my answer. Mudah-mudahan bisa menjawab. Terima kasih.
Thank you, Pak Hammam. Hoping that your questions, your answer can address the question from our participant. Since the time is very limited, with all due respect, we would like to say thank you to Pak Hammam, and let's give applause to him. Thank you, Pak Hammam, again.
Thank you, Pak. Terima kasih.
Ladies and gentlemen, let's move to our next agenda, which is presentation from Mr. Kevin Kim from KevinLAB Incorporated as a strategic partner of Tide Company Limited. Again, as a reminder, the attendees have the opportunity to submit text questions to today's presenter by typing your questions into Q&A box on Zoom or via live chat on YouTube at any time during the presentation. Please mention your name, organization, and to whom the questions are posted. We will then collect the questions and address them during Q&A sessions. But before the presentation begins, allow us to read a brief biography of Mr. Kevin Kim. Mr. Kevin Kim is a co-founder and CEO of KevinLAB and a strategic partner of Tide Co. Limited. KevinLAB is leading the fourth industrial revolution era in energy management field through fulfilling energy management system, ESCO, distributed energy resources, new energy business, and R&D in energy field. Mr. Kevin was the director of IATI Enterprise Corporation, and he had developed the mobile services based on energy management platform, payment system, and business model customer friendly with Korean local banks and credit card companies. He is also the founder of Energy Innovation Enterprise Association, supported by Ministry of Trade, Industry, and Energy of South Korea recently. And without further ado, I would like to welcome Mr. Kevin Kim to deliver a presentation on the intelligent energy demand management platform for smart building and smart home. So please, Mr. Kevin Kim, Zoom is yours for next 15 minutes.
Nice to meet you. This is Kevin Kim. My solution in Korean example. Another. And so explain for our solution is Mr. An.
Present.
Yeah.
With present.
Yeah, we'll present.
Can you switch the screen to mine? Excuse me, Mr. Sharif. Excuse me, Mr. Sharif.
Hello, can you
Can you switch the screen to me instead of the Mr. Kim?
Any, Mr. Kim, you have problem with?
No, I do the speech, the Mr. An.
Mr. An?
Yep.
Could you please post your presentation for Mr. Kim?
Yeah, but I'll do the speech, so you just show up the screen to my face.
Okay.
Yeah.
Please proceed.
Okay. Okay, good afternoon, ladies and gentlemen. I'm Sang-Yan An from KevinLAB and in charge the Global Sales Manager. And today I speak about intelligent energy demand management platform for smart building and smart home. I will go through with you first needs and background, why we need the reformation to smart home building with energy demand management platform, followed by the details about the platform, and third is a strong reference, show how it works, and lastly is who we are. First of all, I just brief about international trend, why we are reforming to smart home and building. Actually, it is about energy savings and reducing green gas. It was started from UN conference in 1992 in Rio, Brazil. And UN announced that UN Framework Convention on Climate Changes was established. At first, they just forced to developed country to reduce green gas. However, it was not so successful, and they forced to join to developing country, not only developed country to take responsible. Although it has many obstacles to work out, it has signed agreement in 2015 in Paris. Following the trend, US presented a policy which is a green button initiative. And they analyze the data and find the saving know-how. And as a result, it brings out the great power reduction as 15 million kilowatt of power reduction, which is equal to 15 nuclear power plants. In Korea, we also try for green gas reduction. We made a policy and bring it with a roadmap. Our target is to drop 37% by 2030. Out of 37% of the target, home and building position about 7.58%. In more details, residential like apartment and private house is about 60% of total home and building energy consumption. To boost up to meet our target, Korean government bring out with Korean New Deal policy. It is to make Korea with smart country through digital transition with data, network, AI. Secondly, make it as green country through balancing among people, nature, and growth towards net zero emission. And third, lastly, Korea make as a safe country through the strong employment market. Therefore, Korean government plans to invest about this market around 160 trillion Korean won, which is equal to 130 billion US dollar. And also it create the 1.9 million jobs till 2025. For the first phase of Korean New Deal, we will transform with smart grid to change with advanced metering infrastructure and improve energy efficiency and reduce green gas. And it expects to reduce 290,000 TCO2 and create jobs, energy transition with renewable energy and zero carbon. Basically, first install AMI and later on utilize the data with Hammam. Another policy is a zero energy building, which we call ZEP. They enhance the policy and it makes as mandatory with the roadmap. It planned in 2014 and it started with a pilot project in 2016. In 2017, it started to build with a passive house. And from 2020, it starts as a mandatory with the public buildings if it's more than 1,000 square meters. In 2025, the private building and public. And in 2030, all the buildings are mandatory to build in JEP standard. Korean JEP certificate standard is as following. It has to meet all three criteria, which is first, building energy efficiency, and second is the BAMS, and third is energy independency. If the building is meet all three criteria, they certify the building as a zero energy building. With the policy, the market will boost up from 2025 and more than 260,000 buildings will be certified and more than 7,000 jobs will be created. Throughout the policy, we are trying to save energy and make efficient, but ironically, it keeps increase every year. It is the first problem. In total consumption, home building is taking 17%, and residential is going to increase 2.59, and commercial is 2.2% in yearly. So government try to find new business with the intelligent home building energy demand management technology. And second problem is a current metering process. Although we are living in hyper-connected and intelligent society, metering system is still limited in old fashion. We're still doing in manual metering system. And it took 2 months to complete from usage until payment. Therefore, I can say we need the intelligent energy demand management platform to solve the problems. Simply, this is the energy demand management platform structure. First, to set the advanced metering infra to collect the data in real time and decentralized power. After that, with shared data, we utilize as a diagnosis, analysis, prediction, AI control with Hammam. Okay, this is a web mode for the Audit. Yeah, it's simply have to utilize with real-time monitoring, remote metering, diagnosis, analysis, reporting, status, and warning and proposal. And it's demonstrated with a graph to compare more easily and clearly. This is the application mode for users like a resident or tenants at home. Except the functions in admin mode, it has more add-on service like a store, IoT control, emission, etc. Especially, it has a time over use calculator, so user can see the difference if TOU is applied. Through the application mode, you can utilize the IoT function as well. You can control the IoT device in application and AI control with saving mode, flash mode, outside mode, and sleep mode. Hammam also has a membership system. It can be a sustainable business model for Hammam. It links to the local shop, and the shop use it as their marketing platform. So users can get the benefit with the rebates or their utility bills. And second is an energy marketplace. They are to promote energy efficient products by online. So the points system, it will make our own community by itself. With the Hammam, we can utilize the data in wide area. However, we should not forget the energy saving is the main point to focus. And AI Hammam is the platform for smart home and building. It is economically efficient and warning to user with real-time monitoring and prediction, convenience, and other add-on services. In the report from American Council, it shows how real-time metering is effective. It shows out the 4 to 12% electricity saving by their feedback. Okay, next is BEMS. In Korea, there are 9 criteria to meet Korean standards for BAM. First, to collect and display all the energy sources. Second, surveillance. Third is such a function by daily, weekly, and monthly, yearly, or selected period. Next is energy analysis. And fifth is performance analysis. Environmental information such as the indoor and outdoor temperature and humidity. And seventh, prediction. And next is a cost of each energy sources. And last is a control system. All the criteria has to meet, and then it can be certified as BAMS. The BAMS function is similar to HAMS, but it is more simplified. And BAMS has a web mode and application mode, but for both mode is for administrator. This is a Korean documentary. It shows the successful case for the digital and Green New Deal with the energy demand management platform. It was in Sejong City and first certified case as a zero energy building with BAMS. It made a great outcome with energy saving efficiency and final JEP certified.
Mr. An, I'd like to remind you, your time is 2 minutes.
Yeah, sure. Okay, and it shows the new ICT technology applied with the cloud computing. In the saving parts, it shows a good result in DR, which is demand response mission. Out of the 60 households, 28 households was participated. And actually, in 2020, entire home and building energy consumption has increased due to COVID-19. So it also increased about 3.9%. However, participated house shows that they saved 17% during the period. It means it can be made more savings if there was no COVID-19. And this is a simulation on our application for TOU. And TOU is basically apply flexible tariff in different charge in peak hour and non-peak hour. And it shows how effective it is. The gray color is for current calculation, and green is a standard TOU, which is with a wide time range of peak hour, like 4 hours as a peak hour. And yellow is advanced TOU simulation, which is a short time of the peak hour, like about 2 hours. So it makes to alert user to utilize energy wisely with the low cost. As a result, it makes to save energy as well. So far, that's all for about intelligent and energy demand management platform in smart home and building. And hopefully you have a great time to understand Korean market. I'm from KevinLAB, and we are venture company specialized in platform or EMS. We achieved patent and intellectual rights and recently got award from Asia Association of Business Incubation. We are supplying HAMS, RAMs, FAMs, and the typical BAMs as well. And we are ready to be expanded to globalization. Currently doing a pilot project in Serbia, and we are setting up an overseas branch in Malaysia as well. Thank you for today, and hopefully you enjoy my presentation. Thank you.
Thank you, Mr. Kim and Mr. An, for the interesting presentations. Ladies and gentlemen, please be patient not to have a question and answer now. Before that, we'd like to move to the presentation from Pak Iwo Prastyo Hadi as a country leader for Council on Tall Building and Urban Habitat. or CTBUH. But before the presentation begins, please allow us to read a profile of Patio. Patio holds a bachelor degree in architecture from Institut Teknologi Bandung and received a master degree in urban development and design from the University of New South Wales, Australia. He got scholarship award from Leadership on Environment and Development 2004 and Australia Leadership Award for Green Building in 2009. He is a professional urban designer and architect, also a founder and CEO of PDW Architect, one of the co-founders of Green Building Council Indonesia. He is associated with World Green Building Council Asia Pacific, country leader for Council of Tall Building and Urban Habitat, and also a professional member of IAI, or Ikatan Arsitek Indonesia, being a representative of IAI for Acacia Committee on Green and Sustainable Architecture. And also, he is in PIA, Planning Institute of Australia, and IAP, Ikatan Ahli Perencanaan Indonesia. And without further ado, I would like to welcome Patio to deliver a presentation on the readiness of Indonesia facing challenges of smart building and smart industrial automation. So please, Patio, the Zoom is yours for next 15 minutes.
Thank you, Pak Syarif Hidayat. Please allow me to start the presentation. I'm sure my screen is up there. Yeah, good afternoon. Well, I'm speaking on behalf of CTBUH as my practice in architecture, also urban designer. First, I would like to introduce you to the organization that deal with tall buildings. The tall building has been built since 19th century up to now. You can see the progress, that the building height from 55 meters now up to 800 meters, and now they are building like a 1 mile tower in Jeddah. They call it Kingdom Tower. Why is it necessary? The drivers of tall buildings are the one of it is the land prices and return of investment. With the cost of land is going up in cities around the world. Second is it becomes a global icon, so icon of the city itself. And the population. By 2025, not far from now, the population will reach 8 billion people. And also urbanization. So more and more people are living in the urban area. Indonesia has reached more than 50% of people living in the urban area. And in US, it's been like 81% in the urban area. And if you see the question, how ready are we? We have to be ready or start to getting ready. Like Riza Hammam presentation, that both existing building and also new buildings, especially new buildings, should adopt the concept. In 2015, Jakarta is the city with the most tall building, above 200 meters. It's 200 meters building is equal to 50-story building. In 2015, Indonesia is the leader. And we can see from the data, Indonesia is ranked 8th of all the countries in the world that have the most tall buildings. 128 buildings above 150 meters, around 30 to 40 stories, and 45 buildings above 200 meters. That is those buildings are buildings that consume a lot, not only energy but also water and all other resources, as well as reducing the burden of the city sprawl, urban sprawl in urban area. There are principles to build tall buildings. I will not mention one by one, but some closely related to smart building that we are discussing now. First is design principle number 2. The tall buildings should relate to the environmental characteristic of place, whether it's light, sun, wind, rain, air. So if we build a building, we should be able to accommodate or to use the potential of our the environmental features of the site. This is one of the example per River Tower in Guangzhou. The building design itself with smart technology, and also designed as such to harness the wind to become one of the energy resources. One of the relation also to smart building in tall buildings is principle number 4, sorry, that should vary with height, not only extrusion of efficient floor plan, so it's just a extruded box, but has to change in scale as the building goes taller. One of the example is Burj Khalifa. The environment can change from floor to floor. This building is 800 meters, so more than twice the tallest building in Jakarta, in Indonesia. It can vary in temperature as it goes up. So this also needs adaptation of technology. And design principle number 5, that we should maximize layers of uses of all systems and materials in the building. The example is a Sony building in Tokyo that it already adopted the new technology of bioskin. So when the facade gets hotter, the pipes on the facade can spray some water to add some cooling, and also during the winter it can also provide heating and so on. And also some of the building concept can harness the wind as shown before. So all the materials, all the aspect of the buildings can be used to make the building more efficient. Now, smart building itself, it will save time, money, and also the environment. So one of the keywords or the underlying of the keywords is efficiencies. On the green building, that tall building will adapt from 17 sustainable development goals. It encompasses at least nine SDGs that's shown here. I'm not going to mention it one by one, but it will help us to build more efficient, to operate more efficiently also. And it also proved that healthy buildings make the occupant perform better. Shorter hospital stays, faster response, more productive workers, and also higher test scores for students, along with the building system itself. With the productivity will increase with better lighting, better ventilation, and individual temperature control. So the comfort is also important in the building sense. These are the 8 features that make healthier and greener office. It really relevant to what the discussion about smart building, how we have a indoor air quality through ventilation, whether it's natural or with air conditioning, thermal comfort. Of course, everybody has the different comfort in terms of temperature, but with smart system, it can be controlled and becoming more efficient. Daylighting, how we use artificial lighting, also use artificial lighting, also daylighting, natural lighting, noise, acoustic, views, etc. Also as well as design. So what makes smart building? That in the reference, that system that the smart building system that collects and makes sense of all sensors. So sensors is one thing we have to measure, collecting data. The data will be those sensors will collect all kinds of information, energy use, space utilization, and as well as productivity, and providing better insight and control over broad range of systems that span the entire building. So we're talking about one building, and the sensor will control, will monitor. But the most important thing, they not only monitor, but also process and learn from all these data the sensors provided. The sensors provide. So it can process the data and help make the decision. They will monitor all equipments from elevators, cooling and heating in some instances.
Patio, I would like to remind you your time is 5 minutes remains.
Sure, thank you. And even coffee machines if necessary. Water bottle, things like that. And what are the drawing the most energy during the day and night? Which area in the building are more frequently used? To plan for optimization of space utilization, and how we plan the maintenance based on work schedule. So which area should be maintained, things like that. And this will suggest ways to remedy inefficiency and reducing utility costs. It orchestrated the whole building, not only individual system. At the moment, we also have a BI, we call it BAS, building automation system. But when you are integrating the whole thing, then it can be orchestrated by a smart building system, improving performance of the building itself, improving comfort for the occupant, and further we can connect several buildings, creating a new efficiency in the neighborhood and city at large. So it will be integrated with IoT system, tracking, sensing, monitoring objects and the environment. This already been shown previously, but by Riza. These are the aspects. I don't need to mention it one by one. But then we now, the most recent technology is electrical vehicle that can also be controlled in the building. That can also be accommodated in the building. For energy efficiency, as mentioned before, lighting sensor, HVAC, and building shades automation. For water efficiency, they can spot the leak, water quality monitor, even gardening, for gardening. And for indoor health and comfort, control fresh air intake and air quality monitoring. The data can be utilized, and you should not require heavy capital investment, but the saving, the efficiency will be significant, and it should provide extensibility for the future, as the technology always progress. And what we call it low-hanging fruit. The data-driven decision making is very important to make a correct decision. And for design itself, we use BIM, building information modeling, that can be used from the design stage until the operation stage. So the whole cycle of the building life. And when it integrated to city network, decision making of the city also can be made accurately. So from smart building, we in larger sense, then we can have a smart city with a correct decision making, because city represent of 80% of CO2 emission and 75% of energy consumption. By creating more efficient neighborhood, more efficient building, neighborhood, and cities, we can have a low carbon life. I think I should go through this very quickly because this is my last minute. So there's 8 actions for urban leader strategies, building codes, target. Very rarely we have targets in our government, in our local government. Measure and track performance, incentive. It's always been also requested by the private sector. Lead by example. Municipal government should lead engagement strategy, how they engage to the communities, technical training. Of course, we need more experts and partner with utilities company like PLN and all the other utility companies. So by that, it's something we can do by the building industry, construction industry. It's not just a building. It also has a change of mindset. And if you cannot measure it, you cannot manage it. So this is very important for the building, operational and construction industry. Thank you. Sharif, give it back to you.
Thank you, Pak Tio, for the presentation. Ladies and gentlemen, now we are entering the question and answer sessions. If there is any questions, but please allow me to post questions, one each for Mr. Kim and Mr. An, and one for Pak Tio. For Mr. Kim and Mr. An, my question is, what is currently the penetration of the proportion of ME to total energy metering in Korea?
Excuse me, sorry, I can't hear it properly here. Hello?
Yes, my question is, currently, how many percent of the metering in Korea is categorized as ME, advanced metering infrastructure, compared to the old-fashioned technology?
Just a moment.
Your mic is still mute, Mr. An.
Okay, because I'm checking with Mr. Kim about the question and I translate to him. Yeah. Okay, he said that it's about 30%. Yeah.
You got my questions?
Yeah, can you hear?
Yeah.
Yeah, you know, because I just translate to Mr. Kim and then he said that it's about 30%.
Unfortunately, I cannot discern your voice. Let's go to the question for Pak Tio. Pak Tio, as we know, Jakarta is now sinking due to the overburden of building as well as earth water draining. How can the smart building concept can cope with the problem?
Well, first and foremost, it can give you early warning. Of course, it will not work if the city is sinking, but the technology can help measuring how's the impact of the building. I mean, if we use the right technology to construct, then the negative impact of construction industry can be reduced, minimized, or even now we are starting in association discussing about restorative economy. So instead of exploiting the nature, creating a building, the building can restore the nature. The extreme example, if you have a mine pit and then you plant something, creating industry, then the land will be remedied, will be made better. and the industry actually can make the environment better. In Jakarta's case, when it's sinking, there are several proposals that a building can be also a barrier, building the dam and building the barrier, and then we can build a property above it, just so we can protect the land. So this technology, the smart building technology, there is technology also to measure how much land is sinking, and we've been talking about this since 40 years ago. So there's no, I mean, it's already too late to discuss we should do it or not. We have to do it. We need to stop taking groundwater, water from the ground, and start pumping, or we have to do all things now to protect the water table, and also to protect the intrusion of seawater from to the land. I think it's a complex issue, but with the smart system, of course, this can be mitigated.
Thank you, Pak Atyo, for a comprehensive answer to my questions. Is it any further questions from attendants? If not, then we will have a break for about 10 minutes to enjoy sponsored video. We will be back immediately afterwards. I return the Zoom to the committee. Thank you for
Tide strongly believes the importance of environment protection and energy efficiency in order to achieve a sustainable future for mankind. Thus, our technological commitment will foster mutual betterment of our allied companies, customers, shareholders, and employees. Tide pledges to always hold their management philosophy and values at heart. Until now, the meter readers have had to do manual meter reading. This existing manual process is time and money-consuming work. This makes it hard for us to detect blackout and manage energy demands. And it makes us hard to manage loss during transmission and distribution. As a result, this existing manual process makes grid unsmarter. But TOT's end-to-end AMI solutions will connect the user with utility companies. TOT's intelligent AMI solutions will solve many problems from the existing manual process. We can reduce time and money spent metering manually. We can manage blackout and loss during distribution. We can do demand response, TOU. Finally, we can make grid smarter. AMI service. Meter reading information of household is call-cited by modem and DCU. There are two types of smart meter, internal and external. Smart meter sends metering data to modem via serial communication. Modem sends metering data to DCU via PLC communication. DCU sends metering data to server via fiber optic and cellular network. On-time monitoring and detection of electrical loss. TOU, time of USC flexible tariffs. Connectivity to electric vehicle charging system. Connection of renewable energy and battery with bidirectional metering. Reliable collection rate improving, monitoring of power quality. Making grid smarter and more efficient. a hidden champion in the energy IoT solution industry. Tide.
At ABB, we're creating buildings of the future today. This is made possible by our cloud infrastructure, known as ABB Ability. Our fully integrated smarter building systems deliver higher value than individual smart components. By adjusting a building's energy consumption to meet demand, our connected solutions provide savings of 30 to 60%. Wherever energy comes from, we ensure it arrives safely and reliably at the point of consumption. Our building automation allows control of every detail, from anywhere at any time, whilst our smarter security systems detect and communicate threats or faults before they become a problem. From factories to offices to homes, at ABB, we are working to find more sustainable, safer and smarter ways to power the world around us. Bringing the future to you today.
Indonesia mengembangkan energi baru terbarukan melalui berbagai fitur pembangkit listrik untuk menghasilkan energi bersih dan juga tetap menghasilkan tenaga listrik yang dapat dimanfaatkan oleh masyarakat. Ini aku dan keseharianku. Semakin intens menggunakan segala perangkat yang berhubungan dengan tenaga listrik. Listrik kini menjadi kebutuhan pokok sehari-hari. Listrik sangat mempermudah kehidupan kita. Dari energi bersih menjadi listrik. Listrik berkontribusi menciptakan lingkungan yang lebih sehat.
Negara Indonesia adalah negara kepulauan yang terdiri dari 273 juta penduduk Indonesia yang kaya akan potensi sumber daya alam. Kondisi saat ini, rasio elektrifikasi Indonesia guna memenuhi kebutuhan listrik masyarakat di seluruh pelosok masih belum mencapai 100%. Indonesia juga masih menjadi negara penyumbang sampah terbesar yang sampai saat ini belum mencapai target pemerintah. Berdasarkan problematika tersebut, sebuah terobosan pengelolaan sampah menjadi energi dengan teknologi olah sampah di sumbernya atau dikenal dengan TOS akan menjadi solusi masalah sampah yang didominasi oleh sampah biomasa seperti daun, ranting, rumput, limbah perkebunan, limbah pertanian, dan juga sampah organik lainnya.
Mudah-mudahan program ini bisa menjadi program nasional dan bisa banyak dukungan-dukungan kami sebagai startup company bisa terus berkembang dan bisa bersosialisasi bersama masyarakat dan UKM-UKM yang ada di Indonesia.
Ladies and gentlemen, after having a break, now we enter the last session for two speakers. Let's welcome first Pak Jiwa Ginanjar. Pak Jiwa Ginanjar from ABB will present the slide on the future of smart building. But before presentation begins, allow us to read a brief biography of Pak Jiwa Ginanjar. Pak Jiwa holds bachelor degree in physics engineering with submajor of control and instrumentation from Institut Teknologi 10 November, Surabaya. Jiwa joined ABB in 2019 and worked across a variety of channels, market segment, and end users. He has extensive experience in electronics and electrical solutions. His technical and commercial expertise is certified by global KNX organizations. He has been instrumental in supporting various smart building related projects in Indonesia. Jiwa Ginanjar is the product marketing manager for smart building divisions of ABB's electrification business in Indonesia. And without further ado, I would like to welcome Pak Jiwa to deliver presentation on the future of smart building. So,
yes, hello everybody. Thank you, Pak Sarif, for the introduction. It's really such an honor for me to present in front of you all. And also thanks as well to the committee to conduct this event. Because this is really my pleasure to present and talking about the smart building in this event. So allow me to share my screen before going to my explanation.
Pak Jiwa, can you hear me? I'm sorry,
Is it my time or Pak Sarif still have some moment?
Okay, we got your presentation.
Okay, thank you, Pak Sarif. So let's talk about the future of smart building. from ABB from ABB. So before going about the smart building, allow me to introduce ABB first. As a company, ABB, we are in ABB position ourselves as a technology company. Why? Because we are really proud and really spend so much our resources for research and development. And then so that's why in some aspect we are pioneering in some technology aspects such as electric vehicle charging, and then robotic system, as well as some another business area within ABB that there are some for business unit electrification, industrial automation, motion, and robotics. And then talking about ABB Indonesia present since more than 30 years ago, with total company in Indonesia up to 500 employees. And we have several factory that's located in Indonesia, such as in Cibitung and also in Tangerang, as well as some workshop in region, such as in Semarang, Medan, Balikpapan. And also we involve so many projects within country, such as for LRT project, as well as smart motor system, usually that utilize in food and beverage industry. Okay, then we go to our session for this afternoon. But before going to the explanation, allow me to play some video regarding what kind of solution smart building ABB. Thank you for the show, and then I continue to my presentation. Okay, so the smart building solution that we talk about. The purpose for this solution is how to tackle the challenges for better future in the building using ABB smart building solution. But before going to what kind of challenge that we need to tackle, we need to understand what kind of building that we are facing. Because why? Because every building have their own uniqueness, they have their own necessary. Let's take some example, like hotel and hospital. If we ask to ourselves which building that we want to go for our leisure, maybe almost all of us prefer to go to hotel for leisure rather than go to the hospital for a treatment. But in reality, if you see in day-to-day activity, in some moment, hotel may be only occupied by few people, but in hospital, maybe especially within these 2 years, occupied by so many, and then in certain certain period last year, we also heard that some hospital cannot cannot accommodate some people for treatment. That's the kind of building we need to understand before we provide what kind of solution, because every building will have their own uniqueness, will have their own characteristic. That's the most important thing. But so because the solution should be based on the needs or based on the characteristic of the building, this is something really absolutely needed. This should be like modular solution, which can be modified based on the necessary, based on the building characteristic. We cannot provide it as a product which only plug and play, but we need to design up to the characteristic, up to the we need to design a proper design, proper solution. So all those challenges will be solved and comply with the requirement of this kind of building. In terms of that, the solution from ABB is like we understand that requirement, but again, not so many or not everybody can spend so many time to only design one building with their own solution. Sometimes we have limited time, so we need to go as soon as possible to provide the solution. So ABB provide like pre-configure and pre-engineering integration of solution that's dedicated for certain of building. This is what ABB Smart Building Solution. It's like pre-define and pre-configure, which can be modified to a certain degree and modified as to be more suitable for the type of building, either for hospital or for hospitality or for industrial building or another type of building. The solution always based on the customer needs. If we define the customer need, usually in ABB term, we are defined for customer needs in the building. First, related to environment performance. And the second, health and the comfortness. The third, life cycle cost and value. And the fourth, future performance. This is for each building will be different, obviously, but these four topics will remain same. Maybe for environment performance in hotel, different thing with the industrial building, and also for the life cycle cost, maybe in some commercial building, the life cycle cost and value need really to be measured, but maybe in hospital or in some data center, because the performance of building not based on the cost of utility, so maybe the index performance will be based on the utility usage continuity. Based on these customer needs, we also can define the performance index for the building. So we define 7 points for the key performance index in some of building. First, in terms of efficiency, well-being for the occupant, and then sustainability, productivity, flexibility, total cost of ownership, and connectivity. This key performance index will be measured and defined to a certain degree what kind of smart building that we will have. Let's say in terms of flexibility, previously we will never think that hotel will be need for a treatment. But since these 2 years, because the capacity of hospital is very limited and cannot accommodate for all the people that infected by the virus, so some hotel modified, or some commercial resident modified to become hotel treatment for quarantine. And actually, this flexibility is needed for the future smart building, because we will never know it will be happen again or no or not. But based on the experience, obviously this thing happen.
Joe, I'd like to remind you that your remaining time is 5 minutes.
Okay, thank you, Pak. Then I only take simple example of building. This is like hospitality environment or hotel building. In the hotel building, there are 3 main stakeholder: guests, customer service, and building estate. With they have their own interests, obviously, and based on the environment performance, maybe the guests much more concerned. But in terms of health and comfort, the operator of hotel is much more concerned, and the life cycle cost and value, the concern will be for building owner. Each stakeholder will have their own interest, and this point of interest should be accommodated by this solution of smart building. And from this point of interest, we have to define which which index performance that categorize. This is in terms of efficiency, in terms of productivity, in terms of flexibility, and etc. Based on this, if we can define all these point of interest, so then we go to the system or to the solution that we can have. In ABB, we have several solutions, and we understand we cannot provide all the solution by ourselves, but we are very open and we can integrate it with others, so we can provide whole package solution as a whole for our customer. In terms of what ABB have, we have power distribution system, room control automation, lighting and shading control, HVAC control, energy management, energy lighting, drive and motors, as well as the EV charging. All those in the below is what main domain of ABB. And in the right side, we also have not ABB have, but this is the domain of third party that we can integrate openly to provide whole package solution. So the solution is based on the system, can such as be load shedding, building automation, smart metering, up to what Pak Riza said related to predictive maintenance. We also can provide all these things. So this is the solution that we have. Before I close my presentation, please behold our state-of-the-art from ABB Smart Solution. The operator, please play the video, our last video. Thank you. Thank you. Back to you, Pak Sarif.
Okay, thank you, Pak Jiwa, for a very interesting presentation. Again, as a reminder, the attendees have the opportunity to submit text questions to the presenters by typing your questions into Q&A box or live chat on your YouTube at any time during the presentations. Please mention your name, organization, and to whom the questions are posted. We will then collect the questions and address them during Q&A questions. Now, let's come to the latest speaker, Pak Andreas Widodo, as a President Director of PT Energy Management Indonesia, as a subsidiary of PT PLN Persero, which will deliver a presentation on pioneering smart building in Indonesia and its challenges. But before the presentation begins, allow us to read brief biography of Pak Andreas. Pak Andreas received a bachelor degree in chemical engineering from Institut Teknologi Bandung and got master degree in chemical engineering from TU Delft, Netherlands. Then he got the doctoral degree again in chemical engineering from Institut Teknologi Bandung. He is now a leader for Ikatan Alumni Teknik Kimia ITB and professional member of advisory board program for bioenergy and chemology engineering and chemical engineering Institut Teknologi Bandung. Masyarakat Konservasi dan Efisiensi Energi Indonesia and Badan Kejuruan Kimia Persatuan Insinyur Indonesia. He also getting involved in several trainings such as energy demand in building from TU Delft, global energy and climate policy from the University of London, politics and economic of international energies from France, and many others. He is now a President Director of PT Energy Management Indonesia. And without further ado, I would like to welcome Pak Andreas Widodo to deliver presentations on pioneering smart building in Indonesia and its challenges. So, Pak Andreas, the Zoom is yours for next 15 minutes.
Thank you, Pak Sarif. One moment, please. Good afternoon, honorable speakers, distinguished guests, ladies and gentlemen. It is really a great pleasure for me to be given the opportunity to speak in this event, to share our, let's say, limited experience in trying to also involve in the development of smart building in Indonesia. And we would like also to share about the challenges that we have faced along the way. So to give you a context to the presentation, please allow me to give some introduction about our company. So our company, PT Energy Management Indonesia, was formerly a state-owned government, owned by the government Indonesia 100%, and we were traditionally known as an energy auditor company. But in 2021, just recently, we were now a part or subsidiary of PT PLN, and since then we have started a transformation in order to improve the thing that we can contribute to the country. So the business line from energy another, now we are trying to become an energy and environment protection service company, where in addition to some energy efficiency project that we have done in one moment please, in industry also we involve trying to, as I mentioned before, the business in green building and industrial park. So let's talk about some background, even if maybe some repetition. Hopefully it will Andreas, the presentation that have been given by other speakers. So in our view, despite the urbanization that may be taking place due to the COVID pandemic, we still believe that the urbanization is one of the main reason for the need of smart building, which is a part of smart cities. So as we can see here, there is a steep trends for people to be living in the city, particularly in Africa and in Asia, in our country, which is predicted in the year 2045 or 2050 to reach about 80 or 70 or even 80%. So this will create a lot of problems in the cities, including like security, social, environment, and so on. So smart city can be viewed as one of the approaches to solve that problem, in which by the use of smart technology in the fourth industrial era, now the approach is not like before, in which you just directly add infrastructure or add additional resources for every problems that appear, but you use you use a more structured plan solution, in which you utilize very comprehensive and fast data to be processed with the all available technology to come up with a recommendation, solution, and prediction, so that resources and in new infrastructure can be deployed more efficiently and appropriately. So actually, what is smart city? Smart city can be defined as a system, to help provide the adequacy for the city and for the citizen to get access to jobs, education, to better environment, in short, the adequacy for basic service and basic infrastructure, and only not adequacy but also resiliency when there are disaster or sustainability for the next generation. So smart building as part of the city. What is smart building? We need to define it from number one is from the goal, which is like has been mentioned before by Pak Hammam and other speaker, to reach sustainability in economic and in environmental and also quality life. In other words, in a social life of the people that inhabited the buildings. And this outcome can be reached by having an output like increasing work productivity and resource efficiency, and also work comfort. And this is all possible by having a certain structure, and all of the structure have been presented, starting from having infrastructure like IoT, and then processing data and so on, up to the service. On all of these are connected vertically and horizontally. So what I mean by saying this is that in doing or in making buildings smart, we have to remember not only the automation, the smart of the smart feature of the building, but we need to consider all the value chain, to come up with the smart system. So for example, for an energy efficient system, we have to be agreed first on the goal and the KPI. For example, what is the efficient building? For example, there are a lot of definition of efficient building. Once we agreed between the owner and the contractor and the other stakeholder, we need to analyze for example, the energy balance. How much energy is actually needed? And then what about the efficiency of the conversion equipment, the distribution, and how to maximize the renewable energy portion, and also to efficiently use fossil energy. This is the basic. And once you set up the basic based on a certain environment and activity and extent of usage of electric appliances in the building, then you can install the smart system in order to make system to be able to optimize themselves if there are changes in environment or there are changes in activity inside the building. So neglecting all the upstream value chain will result in an optimized smart building. So having discussed the definition and the background, that may be important because difference in understanding the function of smart building can result in different action or implementation. Next, I want to discuss a little bit about the driver, the trend, and the challenges that we have experienced. So, in our experience as an SOE, I think in Indonesia, especially for BUMN buildings or SOE building, decarbonization will be a very important driver for building energy efficient and smart building. The decarbonization pressures increasing from the market pressure, the government pressure, and every company need to get the license to operate in the future. And also the smart building likely to be involved in a carbon credit. Now the Kementerian BUMN, the Ministry of State-owned company, and also some BUMN are pioneering internal carbon exchange or carbon credit market, so that in this can help and the government reduce what is carbon footprint. And also the energy efficiency. This is energy efficiency is a part of decarbonization, and also people tend to view that with energy efficiency you will be getting more profit. And the fact that technological advances now is become more pervasive, cheaper, and so on, all of this will drive smart building in Indonesia. And this is the trend of smart building. Let's say one moment. The number of smart building projects globally increased from 5% in 2016 to 12% in 2018. The third of most important all IoT application, and smart city and smart industry are at the top. So smart building, connected industry, I believe they have more driving force themselves to get profitability. But smart building may be more difficult to develop. And this is we believe the challenges, at least the short-term challenges. Number one is culture and regulation. Many people still consider, many businesses consider that efficiency and not renewable energy are still environmental issues only, particularly for non-intensive energy industries. And then this smart system, sometimes when we talk with some BUMN, for example, in the, let's say, industrial park, it may be considered still high in upfront cost. And also because of the availability of financing, the payback is still considered too long, for example. And we still lack of a lot of experts. We believe in doing this business. Next, the challenges and opportunities ahead in the field of electricity, as the theme that are provided by the committee. So everybody knows that without electricity, there is no without internet network, without network and electricity, there is no smart system, whatever the smart system it is. So, for example, and this also a risk if we have a electric system which is not reliable. For example, if someone have diabetes and now there are a system where you have IoT, you can control how much insulin you need to take by the machine based on the data that's sent by the machine to the server. If there is not no good network and also electricity, which for example outages of network or electricity, it will endanger the people will use the device to control his blood sugar by using the IoT. So for building, it can be, of course, it is similar. So in the end, we will need more with the development of smart building. We will need more electricity, power, and also we believe we'll need the smart grid. So the building of smart buildings will improve smart grid and vice versa, because in a city the building contribute to a lot of portion of energy they consume. So this is the effort that some of the government, in this case the SOEs and the Minister of SOEs, in the Minister of SOE now we are starting a program, so-called the SOE decarbonization program, in order to reduce emission by 29% in 2030 and net zero emission in 2060. Doing baselining and setting target for reducing SOE emission, and we are going to make a pilot project for carbon exchange, so that if you build a smart building and you reduce energy and you have smart meter which can prove that your energy is reduced, can be sold as carbon credit given appropriate verification. And also government from energy minister also would like to promote a smart building by doing some pilot project in government-owned buildings and BUMN buildings, which we are in talk with some national lenders to make this pilot project. So Pak Sarif, we have talked about the background of the importance of smart building and then the challenges that we are facing, and also some solutions and some programs that hopefully will help increase the growth of smart buildings in Indonesia. Thank you, Pak Sarif. I would like to give back the time to you. Thank you.
Thank you, Pak Andreas, for a very interesting presentation and also a very short time. That's very good. Okay, ladies and gentlemen, it's time now for the second question and answer sessions. We are now going to take questions from Q&A box and Zoom live chat. Let's invite Pak Jiwa and Pak Andreas to keep their camera on to join us with the discussion. As a reminder, the webinar participant can still submit questions through Q&A box and live chat. To begin with, I have 3 questions, one for each speaker, and the third question is for bots. My question is first for Pak Jiwa. Does smart building means the use of controlled space and environment, or can it be a more open system utilizing natural lighting and natural air flow? Again, my question to Pak Jiwa is, does smart building means the use of controlled space and environment, or can it be a more open system utilizing natural lighting and natural air flow? For Pak Andreas, my question is it any example of your company's product and or services in smart building or industrial automation in Indonesia? Again, the question for Pak Andreas is it any example of your company's product or services in smart building or industrial automation? And for both of you, how can we cope with the issue of cybersecurity on smart building and smart living, especially when Andreas led in the last one give an example of insulin injection smart. We see in some movie that somebody is being hacked, yeah, for being diverted from normal medications to the dangerous one. And also we see in the movie, that's Hollywood. Anyhow, we can see in the what is it when American citizen get angry with the government and hack the system, so that crash and power collapse. That's for the initiations situations for each of you. Maybe Pak Jiwa first.
Okay, thank you, Pak Sarif, for the question. Very interesting question. So related to your first question regarding a smart building, is it only consist of controller and sensors, or is it also can utilize as well to utilize natural lighting or natural airflow? Yes, the definition of smart building solution actually can be enlarged or can be enhanced up to the certain degree. And in this case, actually, we also can utilize natural lighting, because in some way, our ABB solution, we have like such as shading control or to operate motorized curtain. So combining with the lux sensor or lighting sensor, how much the lumens that needed in certain area, when the windows fully open by opening the and let the natural lighting flow into the internal area, and then the ambient will be adjusted by lighting control. So we combine between natural resources such as natural lighting and natural airflow with the conventional or modified lighting control. That will be much more our preferences, because this our in ABB actually we also have like a mission to zero, because by mission to zero, one of the target is to decrease CO2 or carbon dioxide footprint. So when we can utilize and combine with natural resources, it will be much more. We are in the stage to build something like that, Pak Sharif. Is it
Okay.
answering your question?
Yeah. And for the second question regarding the security,
cyber security
issue.
Yes. Yes. As you know, in ABB as whole company originally coming Europe, cyber security actually this is our really concern. And if you know as well, in Europe there are some like cyber security rules, GDPR, that's related some network or some operation that's through the cloud. If you see or if you really aware, some of operation through cloud only allow in terms of monitoring only and advisory only, because this is related to the GDPR and cyber security related issue. So in terms of control, remote control, it will be not through the online or not through the cloud, because from GDPR perspective still not allowed. And in some ways, ABB ability that's based on the cloud as well, working together with network security system and network storage system that provided and accommodated by Microsoft Azure, which is quite stable enough in terms of cyber security as well. That's the answer for from ABB perspective, Pak Syarif.
Okay, Pak Andreas.
Thank you, Pak Syarif, for the first questions. So, like I explained before, we have just started to do the smart building business and also the industrial energy efficient business. So our experience, frankly, is still very limited, but we do have some experience. For example, in the industrial sector, we have doing the engineering, procurement, and construction until commissioning of, for example, energy efficient wastewater treatment on oil and gas project in East Java, and within 1 month will be started up. Yeah, in this system, by designing a technology with the Bandung Institute of the Technology, the chemical engineering department, we are able to win a bidding where in our system, the system only consume 1/3 of the competitor electricity consumption. But this is not related to smart industrial automation, rather, but this is still related to effort to make the industry is more efficient. And with regard to smart building, we built some energy monitoring systems in some big women, like in PGN and some other big women through the synergy. And I believe with ME becoming a part of PLN, we are now projecting a lot of project in the future. We are planning to do this with related to the decarbonization pilot project, and also we are open to making a strategic partnership with others company who is more experienced on this regard, and do some transfer of technology. And with regard the second questions, the cybersecurity has been discussed by Pak Jiwa Ginanjar. What I was talking before is more related to the security of the system, related to the availability of reliable, network and power. So we have experience. For example, there are some outages now. Is a big problem for everybody, even in our home. And now the power, the electrical power is, for me, is like air. You cannot live without electrical power. And so by having some reliable, specifically having a smart grid, I believe this can improve the reliability of let's say the smart system in every aspect of our life. That's maybe the answer that I can provide.
Okay, thank you, Pak Andreas. There are two questions for Pak Andreas and other two questions for Pak Jiwa. First, I would like to pose the question for Pak Jiwa. Is from Pak Joni Julkifli. Pak Jiwa, how to effectively and efficiently transform building which are already employed BAS and EMS to smart building? That's the first question to Pak Jiwa from Pak Joni. The second question to Pak Jiwa from Pak Jainul from PLN is, what strategies can direct the behavior of building owners, operators, and occupants toward the improved interaction with smart grid? I think let's focus the first two questions for Pak Jiwa. Could you please address the questions, Pak Jiwa?
Yes, thank you, Pak Sharif. So related to first question, how effective that we transform our the existing BAS or EMS to smart building. First of all, it will be regarding about the effectiveness. It will be depend on the scale, which means when we talk about the effectiveness, we have to compare two positions from starting point and to end point, which is everything will be need to be measured up first. How the scale and how the gain that we can have. It will be very. The probability related to the effectiveness, I cannot answer with real exact answer. Like I said, it will be really depend on how we measure from the starting point. When we talk about BIS only save maybe the gain only save 5%. So with in terms of utility saving or something like that, by smart building, is it can save up to furthermore. That also will very depend on the type of building as well. That's for the first question, Pak Sharif. I thought is it properly answered or how?
Okay. Thank you, Pak Pak Jiwa. And next, two questions for Pak Andreas. First question is from Pak Jainul in PLN. The question is, can a smart grid, especially in Indonesia, increase the vulnerability of the electrical grid and building control system? And can you give me an example in European countries? That's first question. The second question to Pak Andreas is, are there any level of smartness in smart building? Is the level shown in the certificate of smart building?
Can you repeat again the second question, Pak?
The second question to Pak Andreas, are there any levels of smartness in smart building? Is the level shown in the certificate for smart building indicate that smartness?
Okay.
Apologize, Pak Sharif. My answer only for my my first question. Is it okay for me to answer the second question first, Pak Sharif?
Okay, please the second. Oh, I'm sorry.
Really apologize. Yeah. So related to what kind of behavior that need to enforce toward building owner, employees, and also guests related to smart grid. First, we have to understand the scale of utility usage, especially for the building owner. Are they really aware about their utility usage? Sometimes when they got some bills suddenly high, is it they really aware? Maybe there are some harmonic or some disefficiency in terms of the usage. So the first thing they really need to know the detail utility usage before related to smart grid, because otherwise they will always asking around why my utility bill getting higher and higher, and that need proper education, which product or which appliance that can generate such a power quality issue that and eventually make high bill in terms of utility bill. The education of about the power quality is really need, and the second one is the we need to define the key performance index of utility that improve the smart grid solution, and because by continue monitoring, everybody know the situation, so nobody can nobody cannot be blamed or not feel that only get need to pay higher than usual. And then the third, after monitoring continues, prevent such an action, especially for operator or for gas that causes the electricity getting bad towards or something like that. So the usage and as well as the sustainability will be keep on the certain level, not cross the line, and the grid will be always on. That maybe my answer, Pak Sarif.
Okay, thank you, Pak Andreas.
Thank you, Pak Sarif. Thank you, Pak Saino, for the question. Pak Saino himself actually is more expert than me in this matter, yeah. But okay, I will try the question from Pak Zaino. I think there is, you know, for the smart grid, of course, it offers some more reliability from certain aspect, but also Pak Zaino reminding me that there are some also increased vulnerability from other aspects. Yes, of course, for all of the connected and smart system, we have the cyber security risk, yeah, for the vulnerability. I think that is a short, very short answer from me. For number two, are there any level of the smartness of the smart building? Well, I think so, because in the smart system you have different subsystem. So, for example, you have the AVSC smart HVAC smart system, then energy smart system, subsystem, sorry, and then firefighting system. All that are already mentioned by Pak Hammam. And you can have automation by first thing is for each of the vertical subsystem. So from the infrastructure to data to services, that's called the vertical integration. Yeah, and number two, you will have when you increase the smartness of the building, you start to make a horizontal, you know, integration where all of the data are combined for subsystem and share to govern the whole system. So of course, like smart city, you can build step by step. And also for the smart building, I believe you can build step by step what is the most important to us. So that's somehow will give you, if you like, some different level of smartness of smart building. Whether you can have a fully autonomous buildings, which is maybe, and then maybe you can have semi-autonomous buildings. So of course, there is some different degree for this. This is what I think. Thank you, Pak Sarif.
Okay, thank you, Pak Andreas. By this, we will end our session of question and answer. Sorry for the limited time we have. Many thanks to all speakers for taking part in this webinar. We enjoy having you with us and appreciate for your expertise and insight. We believe that the knowledge you have shared with us help the development of the smart building and industrial automation sector. And for you, all of the attendees, we would like to say thank you for your patience to follow the presentations. Let's wrap out our last episode today. Hopefully, this Smart Grid webinar series can trigger for a future cooperation, especially in sustainable energy sectors. Lastly, as requested from the organizing committee, we will have a photo session with all speakers. So please, all speakers, switch on your camera for a while. We will take count on 3, 2, 1 for taking pictures. When ready, please committee to take the picture. Finish? Thank you. As mentioned earlier, the Smart Grid webinar series is supported by PT FIAR and Persero and sponsored by Tide, Huawei, EPCO, Hitachi, ABB Power Grid, Siemens, ABB Sakti Industry, Trillian, Wärtsilä, LS Electric, GE Grid Solutions, Mitsubishi Power, PT Indonesia Comnet Plus, and in partnership with Think Smart Grid Friends and Energy Academy Indonesia, or IATI. Thank you again and have a great rest of your day. See you in next future event. Thank you.
Thank you, Pak. Thank you, everybody.
Thank you, everybody.
Thank you, Pak Tio, Pak Andreas.
Terima kasih, Pak Sarif, Bapak-Bapak,
dan
semuanya.
Pak Hammam.
Thank you, Pak Tio. Salam
See you next time.
juga.
Terima kasih, Pak.
Terima kasih semua, Pak Andreas.
Thank you.
Bisa baca.
Indonesia mengembangkan energi baru terbarukan melalui berbagai fitur pembangkit listrik untuk menghasilkan energi bersih dan juga tetap menghasilkan tenaga listrik yang dapat dimanfaatkan oleh masyarakat. Ini aku dan keseharianku. Semakin intens menggunakan segala perangkat yang berhubungan dengan tenaga listrik. Listrik kini menjadi kebutuhan pokok sehari-hari. Listrik sangat mempermudah kehidupan kita. Dari energi bersih menjadi listrik. Listrik listrik berkontribusi menciptakan lingkungan yang lebih sehat.
Negara Indonesia adalah negara kepulauan yang terdiri dari 273 juta penduduk Indonesia yang kaya akan potensi sumber daya alam. Kondisi saat ini, rasio elektrifikasi Indonesia guna memenuhi kebutuhan listrik masyarakat di seluruh pelosok masih belum mencapai 100%. Indonesia juga masih menjadi negara penyumbang sampah terbesar yang sampai saat ini belum mencapai target pemerintah. Berdasarkan problematika tersebut, sebuah terobosan pengelolaan sampah menjadi energi dengan teknologi olah sampah di sumbernya atau dikenal dengan TOS akan menjadi solusi masalah sampah yang didominasi oleh sampah biomasa seperti daun, ranting, rumput, limbah perkebunan, limbah pertanian, dan juga sampah organik lainnya.
Mudah-mudahan program ini bisa menjadi program nasional dan bisa banyak dukungan-dukungan kami sebagai startup company bisa terus berkembang dan bisa bersosialisasi bersama masyarakat dan UKM-UKM yang ada di Indonesia.